Just going to record some videos for Hugo, because Hugo's away for a whole week, or at least, getting his tonsils out. So everyone needs to say, hello, Hugo. Hello. We hope you're okay. All right, cool. So, in doing so, I'm going to put these on the website. So this is essentially, you can redo this lesson at home, okay? So I'm going to try and do that a fair bit with maths in particular. All right, for the next week at least. And if it works, I'll just keep doing it. Okay, so Thursday, week 1, equivalent fractions. Hopefully from watching those Khan Academy videos, you're able to now know that to find an equivalent fraction, you can do one of two things. What are they? To the numbers.
You can divide them.
Yeah, you can divide them. Half of them would be dividing to. Or, not add them, no.
Minus?
Nope.
Well,
Kearney, multiply them. Yep. Okay, so in your notes, you're going to write down, after you've written Thursday, week 1, equivalent fractions, you're going to write down to find an equivalent fraction. You can either multiply or divide. Now, the easiest way to do that is to double both numbers, or you can halve both numbers, which is essentially either multiplying or dividing. Okay? You just have to write that down.
yes. In one video, I saw that it could have been a different place, but if you add if you add like you can find it in the hole and
It can, yep. Okay, so the most important thing to remember with equivalent fractions, and if you don't do this, you will get them incorrect, is that whatever you do to the numerator, you must do to the denominator, okay? So if you're not doing that, you're actually just changing one part of the fraction and it becomes something totally different and a different value fraction, which is not finding equivalent, it's changing it to something else. So that doesn't work. Okay, so that's the second point you need to type up. You must do same operation, so divide all times, to both numerator and denominator. Okay, very, very, very important. So as I said, really important that whatever you choose to do, be it divide or multiply, that you do the same thing to the denominator that you do to the numerator, or whichever one you end up doing first. Now, a lot of the time it's easier just to multiply the numbers to find an equivalent fraction or to recognise an equivalent fraction. But if the fraction is already really big, then dividing might be your best option as well, okay? So, a lot of the time, for these sorts of questions, there's actually multiple answers because there's lots of different ways that you can multiply, lots of different numbers you can use to multiply. So that leads us to almost endless answers, actually, okay? But some are more obvious than others, okay? So, in your maths book, can you just make sure you've got the heading equivalent fractions, please? Okay, and then we're going to do 6 practice questions. Alright. So, I'm going to write a fraction up, and obviously I'd like you to write an equivalent fraction to that fraction. Okay, so the first one is 3/5. Okay, and the way you would write it would be write the fraction then the equal sign. Okay. Now when you look at this and you know that you've got two choices, one is to divide or one is to multiply, what's the one that you would choose for this fraction?
Multiply.
Why?
Because it's a small number.
And it's an odd numbers, they're both odd numbers. So if you're dividing, and we know that these are actually what sort of numbers? Also odd, they are prime numbers. Great. So we can't actually make these any smaller by dividing them and keep them as a whole number. So you're going to multiply them, yeah? Okay. The easiest number to multiply them with is 2. Okay, so we'll just try that. This is a setting out that you would need to use. Okay, writing next to each number what you've multiplied them with by, and of course that would be the same top and bottom. Okay, so 3 times 2 is
6.
And then 5 times 2.
Oh, I get it.
Yeah, cool. Perfectly correct answer. But as you can imagine, there's multiple answers to this defining equivalent fractions here. What would be another answer? 12 out of 20, so you've just doubled it again. If we times it by 3 instead of by 2, we'd have 3 times 3 is 9, and 5 times 3 is right, so 9 out over 15 would also be correct. Okay, 33 50th.
If you times them both by 10.
You would have 30 50ths, yeah.
Yeah.
So as I said, like endless possible answers. Okay, the next one.
Or 300, 500. Well,
okay, for this question, I would like you to do it twice. One by multiplying and one by dividing, please. But what you choose to multiply and divide by is up to you. Okay, so multiplying, first one. Oh, sorry, it doesn't matter. Whatever.
You could
Doesn't matter.
technically go for the 6 tenths and then 3/5. You can do 3/5. 24.
Okay, tell me their oh, sorry, give me a second. Sorry.
This is an easy one. It's the same answer as last week.
Just watch this one. Okay. Ready to go? Who wants to share their multiplied equivalent fraction? Adriana?
So for the dividing,
Multiply?
for the multiply, I had 12 times 3.
Yep.
And 20 times 3 is 36 times 60.
Okay, great. If you just doubled it, which I reckon lots of people did, you would have had 24 over 40. Cool. Okay, and the divided one, please.
12 divided by 4 and 20 divided by 4 is 3/5.
Awesome. If you had divided by 2, 6 over 10.
Yeah.
If you had divided by 6, okay, you would have had 2 over 3. Okay, 2 over 3. Oh, not 2 over 3. Divided by 6, you can't divide by 6, sorry. If you had divided by 5, no, you can't divide by 5. That might be all. 9, 4. 4.5. So what we've actually done here, which is actually our next topic, is we have simplified this down to its lowest form, kind of by accident. Okay? So that means that I can't make this number any smaller, and they're prime numbers anyway. So by accident we've made this as small as possible in terms of how the numbers. Okay, that's called simplifying to its lowest form. Okay, I'm going to write 4 more down for you. Once you have written them down, you can go and get your crunch, come back and eat it whilst you're working out the answers, and then we'll have a break for bathroom. Okay, so number 3 is 72 over 84. So you have to find me an equivalent fraction. Now, like I said at the start, sometimes whether you should divide or multiply is obviously a better option. If your number is already really big, don't make it bigger by multiplying it. See if you can make it smaller. Okay, intentionally. Alright. So for these, you don't have to do them twice, just do whichever one you feel is appropriate. Okay, but please show your working by telling me what you've done with both of those. Alright, so as I was saying before, some of these will most obviously be better either divided or multiplied. So, a couple of people asked me before, if you can get it to its lowest form like this one, should you try? Yeah, absolutely. Okay, so as in you can't use any number to divide it anymore except for 1, in which case it would just stay the same. That's what we call our simplest form, okay, or lowest form. Okay, so this one already has quite large numbers as the numerator and the denominator. So what's the best way to go about this one? Yep, Rafa? Division, okay. So what did you divide yours by, Rafa?
Divided by 2.
Okay, because they're both even, that's pretty easy to do. What did you get?
I got 36 over
36 over. Cool. Thank you. Alright, perfectly reasonable. That's fine. What is another number that you could have used?
4.
4? Did you do that, Kieran?
Sorry?
Did you do that one?
I don't know.
Okay. Did anyone else do 4? No, it would have worked out just fine. That's fine.
We divided by 2 and then we could see that we could divide it by 2 again.
How did you know that?
I divided this.
Just a minute. Because they're both even, yeah. So you could have gone 2 and then done 2 again, in which case you'd be doing it by 4, but that's fine. And that would have broken it down further. What is the biggest number that you could have divided by to not have to keep breaking it down and down and down?
7.
7.
6. No. 8. 12.
12, yeah. 12 is what we call the highest common factor, okay? So that's the largest number we could use to get to the end result the quickest in this case. Okay, so 72 divided by 12 is?
6.
And, is that right?
Yeah.
Yep. And 84 divided by 12?
7.
7.
That's not that.
Okay.
Divided by 12. Yeah. Jake is right. Because 6 times 6 is 36, then Jake is right. And 2 times 9 times 12.
Yeah. So 2 lots of 6 divided by 60. 6 divided by 12.
Again.
Cool. So that was divided by 12. Oops. So I've sort of jumped a step there, and that just saves you time. That's really good. And that what comes with your really good knowledge of your multiplication and division allows you to recognise that sooner. Okay? Alright. Divide or times for this one is totally fine. Who times 6 over 8? Will, what did you get? Or what did you do?
I did 2 times. Way easy.
Yep.
And you get 12 16.
12 16. Great. Okay, so you could have also divided and broken it down to its simplest form. You would have divided by 2. Yep, great. And you would have got 3 quarters. Okay, cool. Lowest form there. No other number but 1 goes into 3 and 4 together. Okay? So you might be able to break the 4 down into 2, but that doesn't work for the 3, so it's not an option. Okay, 24 over 8.
You can pour in the down all the way to 1.
Not to 1. You're on the right track. Yeah.
I divided it by 4.
Yep.
And I got 602.
Okay, so it is an improper fraction, and that would lead you to think, well, maybe I might be able to get a whole number at my end. Okay, so let's just go gradually. Sorry, what did you say that you used? Who did that one, sorry? Raph, what did you say?
I divided it by 4.
Divided it by 4?
Yes, and 602.
and you got 6 over 2. Can you then break these down further?
Yeah,
what number
yeah.
goes into 2 and 6? Janice?
Well, for divide it by to get to lower, which would be 3.